Need one of those boards.
I do need one of those boards, right? The like formal, I don't even know what they're called. Yeah, action. All right, so we're here in the Pipeline Media Studio, and it's our inaugural use of the studio. Super exciting. And we've got Matt Ketterer here, who's one of our esteemed team members. And I thought it would be a bit of levity if maybe we could start by talking about how you first became aware of me and Pipeline.
Sure. I was working at a medical device diagnostics company in Tucson, and I had seen, I think the first contact was I got basically a cold call email sent to my inbox, and I remember opening it, and I don't remember if it had pictures or not, but I was intrigued enough to go look at the website. And when I saw the website, I thought it was really nicely thought through. Like, obviously the graphics and everything and the logo, like someone had spent time thinking about it. And then I started looking at the equipment, and there were not like big machines, right? There were a lot of smaller machines, but what caught my eye was how well finished they were and how well thought out they were. Like, they looked really high quality. And I thought, oh, this company's just starting out, but it looks like they're heading in a good direction. Like, they're doing the right things. And the biggest thing that stuck out to me was I remember you had your picture in the email, and I looked at that picture, and something about it, when you look closely, I can tell this is not the case, but whenever I first look at it, even to this day, it looks like you're wearing an ascot and you just have this smug look on your face. And I thought, man, what a smug prick. Great company, but man, what a smug prick. And this guy keeps emailing me like every week. But I bookmarked it, and I kept it in mind. I'm like, I'm either going to work with those guys or work for them eventually. Like, I think they're doing good things.
And very large gratitude that Matt is with us now and has been for some time. And it's been a wonderful, wonderful experience for all of us. So that, I always think that story is funny because I had a totally different experience. I remember emailing you and reading about your experience, and I thought, oh man, this seems like the perfect guy to contact. We could probably help them out with some automated equipment. And yeah, I would send, I don't know how many emails I sent, probably 8 or 10 or 12 over the course of, maybe I'm underestimating, but a bunch, right? Not a single response ever. Not one indication that he had ever opened or read or had any awareness whatsoever, which was by design, I know. And then years later, when we finally how did we finally get in touch? Did someone make an introduction?
Yeah, it was a colleague of a colleague. So I worked with a really great software engineer for a long time that I met when I was back at ATS. And we subsequently ended up working at 2 other companies together. And when we both had left the final company, a guy that he had worked closely with in the past, Bill Orinsky maybe?
Oh, yeah.
Yeah, so he had worked for Bill Orinsky for years. He knew him very well. And Bill had reached out to my friend Paul on your behalf when you were looking for a controls engineer for a big project. And Paul recommended me to Bill, and then Bill contacted me. So he kind of called me out of the blue, and I was like, I know this name. And he said, oh yeah, Paul gave me your name. He said, he's not interested, he's retired, but you'd be a great guy. So I was like, oh, this is, fortune here. Yeah. Things are aligning.
That's right. Well, thank goodness it did. And so this was, years after I had first started harassing Matt with all these. I think there were probably some voicemails in there as well.
Probably were, yeah.
Not just email. I didn't stop there. And I was harassing him as, trying to solicit a lead for work, but things came full circle, and now we get to work together. And I have since changed my picture on LinkedIn.
I appreciate that.
Following.
Very
appreciate that. This is what I appreciate about Matt. I get very candid feedback from him, which is so important and so valuable.
I found in my career, it was interesting. At some point, I realized early on in my professional career, I was, somewhat deferential, not really afraid to speak my mind, but I'd stay away from certain things. And I found as times went on that people responded better when I was more authentic. So I try to really make a habit of just putting it out there, whatever I'm thinking, and I've gotten better at doing it in a nice way if it's not great stuff. But
And I'll say I've received many pieces of feedback from Matt to date, some of which have been very positive, others have been critical, but it's always been very professional. I never felt like I was being attacked. It was always a very appropriate lead into a worthwhile conversation. What we're planning to do with this episode of the podcast is Matt just has so much experience in engineering, mechanical design, controls. We'll get into it. He started in mechanical engineering, moved into automation, control software, but he has so much experience. And so we're going to just do a general podcast episode like we often do, interview Matt, learn about him, tease out some best practices and some insights that we can all use and apply to our work. And then we're going to use this as an opportunity to identify a few specific topics that at a later date we can dive into in greater detail and probably do some shorter, 2, 3, 5 minute segments about some very specific details and get some more in-depth advice and feedback from Matt on some of these. So that's already a great one right there that we don't need to dive into detail right now because that's what we'll do in the future. But speaking your mind and being assertive in a professional and respectful manner.
definitely a skill. It took some time to master.
I believe it, yeah. So let's go back to the beginning, Matt. How did you even get started in engineering?
I get started in engineering. So I grew up, my parents are both teachers. My father is a mathematics teacher and my mother is an art teacher. So I had these two kind of right brain, left brain parents, right? So they always encouraged me to be creative and they always encouraged me to make things. My dad was always doing woodworking and fixing the car and making all kinds of things like that. And my mother was always making art and all kinds of, projects in that realm. So I got a lot of opportunity to do both. And they were both very curious people as well. And my dad would always teach me different things. A lot of times it was things he was teaching in his class or that he had found interesting from a conference or something about math or teaching or science. He went to a lot of additional conferences to learn extra things. And so I remember things like one point he came home and had this book on paper airplanes. And he's like, yeah, this is the coolest thing, check this out. Had all these wild designs. So we talked about aerodynamics and we would try making all these planes. And we happened to have a house that was small but tall. So we had this balcony and we could throw airplanes off it and see if we'd get them to go all the way across the living room. So we do, experiment with different wing designs and flaps and trying to make them do barrel rolls. So he was always doing things like that. Or he'd take me in the garage. I remember one time he took me in the garage and we had, you don't see them too often anymore. We had one of these big batteries. I forget what the cell size is, but like a big rectangular battery with 2 terminals on top, like spring terminals. And he's like, hey, you know what's cool? Like you can take one of these and a nail and some wire and you can make an electromagnet. Like, yeah, let's do it. So, he showed me how to wrap the wire and we wrap it around this big nail and then we go around picking stuff up. So he was always doing cool projects like that with me.
That's so funny that you mentioned that. My dad taught me the exact same thing.
Yeah.
I don't think we used the giant magnet. We just had some D cells and we'd, put one end of the wire in one end of the cell and the other end on the other end. But I thought that was endlessly really fascinating. Cool, right? Yeah. He
also always encouraged me to use his tools. He always had a big, I don't know what you'd call it, a tool room, right? Or work room. His media of choice was wood. He liked to work in wood, but he had all kinds of tools. And so he'd, teach me how to use a bandsaw, teach me how to use a table saw or whatever, make all kinds of things. The entryway into engineering is interesting because I actually, when I came out of high school, I had no idea what I wanted to do. I was a I was like this goth kid with long hair, was into music, you know, in a band. And I knew I liked movies. I'm like, I don't know. My parents were telling me I have to go to college. Maybe I'll go to film school and I'll make films, right? Make cool films. Turns out I'm not that creative. But I went to, I tried going to film school and it was at Temple in Pennsylvania, in Philadelphia. And I made it 1 year and I failed out of school basically. Just didn't go to class, failed everything. It was terrible. Like, this is definitely not for me.
Didn't go to class because it wasn't interesting?
It wasn't interesting. Yeah, didn't like it. Had to, I don't know, we had to do a lot of weird, soft things that I just wasn't into, like, oh, make a piece of art and write a essay about it. And it just wasn't speaking to me. I wasn't relating. So I dropped out of school. Actually, in that summer, I hooked up with a buddy of mine from high school, and he was living in New York City, in Brooklyn, and he needed a roommate. His roommate had just moved out, and he was up there going to art school, and I forget what work he was doing. He was working as a graphic artist or something too, and he's like, hey, I need a roommate. You want to come live in New York City? So I moved up there. I think I made it 4 months up there. It was like I guess 19 years old at that point. No job experience, right? No skills. And I'm like, I'll just go there and get a job and it'll be great. And I'll live in New York for a while. Well, I ran out of money. I had done some like handyman work for the landlord, but I went around looking for just entry-level jobs, like cashier jobs and stuff. Nobody's going to hire me. I didn't have a New York driver's license or anything, and couldn't get hired. So I moved back home, and then I had met my first wife at that point, and we ended up moving in together. And I was moving furniture, and she was processing loans for a bank. And these were like, at the time, it was like $8 an hour jobs, right? We were happy, but we were looking at the finances and we're like, this isn't going to cut it. You know, we already had one child, my son, and we wanted to have another, and we didn't want to wait a long time. We're like, these jobs aren't going anywhere. We got to do something. And we decided that I had the best chance for a good return on investment going back to school. So I applied to engineering school, and then I went. And I think the idea for engineering school really came about because my dad had gone to a conference in Florida. It was like space camp, right? So he's at the Kennedy Center or something, or is it Kennedy Space Center in Florida? Yeah. And I remember him coming back and being really excited about it. And he brought me this book all about engineering for space. And I read that thing cover to cover several times. And he told me the stuff that they did while he was down there. He's like, yeah, we made wings out of carbon fiber and tested them in the wind tunnel. We did all kinds of cool stuff. And then I'm reading about all the, mechanics of space flight and, how rockets achieve liftoff and how the center of mass doesn't actually move because you're ejecting as much mass as you're moving and all this really cool stuff. So I sort of had an idea like, oh, maybe engineering would be a cool thing to do. So I applied to engineering school, kind of took a big risk. We didn't have any money at the time, and probably because I was a college dropout, they didn't want to give me any grants and definitely no scholarships. So they told me, like, hey, you pay for your first semester, and if you do well, then you'll be eligible for grants and scholarships. I was like, all right, we can do that. So we had 2 cars, 2 old junky kind of cars that we owned, and some other basic furniture and things. And we sold both of our cars and everything else that we could. And we paid for my first semester at college, which was quite expensive, especially at the time. And we moved into married student housing on campus so that we didn't need any cars, and, didn't need anything. And I worked my ass off. It was so stressful, but I got on the dean's list that first semester, did really well. And then I was able to get grants, scholarships, and some loans, and made it through the rest of college that way. So
that's amazing.
It worked really well.
An inspirational story already.
Yeah, it was it was brutal because I did it in 3 years in my engineering degree because I didn't want to pay for year 4.
So you must have been taking 18, 20 credits.
It's taking a lot of credits and also going in the summer. Yeah.
I did mine in 5 years.
Yeah. Well, I mean, there's all kinds of ways to go about it. This was of necessity, you know.
I'm sure it was brutal at the time. Do you look back on that period with any fond memories, or is it just, I'm glad that's over?
So for a long time, I had the stress dreams of oh, I can't find my class. I didn't finish my work. I'm behind on everything. But yeah, I look back on it fondly. It was a good time. I mean, we had, it was my wife was pregnant at the time. We had my son and we were all in an apartment and just super poor and taking the bus to go to the grocery store on the weekend. But looking back, they're definitely fond memories.
Yeah, right.
Wouldn't want to repeat it.
Yeah, understandable. Okay, so you got through school, and then you started full-time work, and we don't need to go like super detail what you did in every job, but a couple minute summary. Where did you start, and how did you progress through different roles to where you are now?
Yep, I started in college. It was hard to decide between engineering disciplines because I'm a curious person and I found them all very interesting. And it came down to between mechanical engineering or software engineering. And at the end of the day, I was like, there's a lot of stuff about mechanical engineering that I would have difficulty learning on my own. Software engineering, I felt like, was something that I could supplement and learn eventually. So I made the decision to go mechanical and graduated with that degree. And my first job was with a medical company, a German medical company, Bibron Medical. They're a pretty big international company. And I worked in their OEM engineering division in their plant in Allentown. So there they hired me. I was designing venous and arterial access products. And then I was also responsible for the manufacturing or for the equipment that was used to manufacture them. They had just purchased a little company that they were integrating, and they kind of put me on this project. They're like, hey, we bought this equipment from this company and this product line, and we want to be able to make variations of these products for other customers. That was the OEM part. And then we also have to understand how these machines work and how we can make new tooling to make different size, different lengths, all these kind of things for parts. So it was a really fortunate job for me. The products themselves were not terribly interesting, right? They're essentially tubes in varying lengths that have a tapered end, and then they would get a hub over molded on the end, insert molded. And not terribly interesting by itself, but it was a perfect starter thing to learn on because I learned about extrusion. I learned about how to tipping of tubes, how to make tapered tips on tubes. And I learned about insert molding, which also taught me just about molding in general. And the company was completely, or probably still is, completely vertically integrated. So we would get carboys of raw material. They had a whole area of the plant that was extrusion, several extrusion lines that we would run, and we'd run our own custom stuff, and we'd run stuff for production. And then we had our own, actually, tool-making engineers that would design mold tools. We had a mold shop that would make mold tools, and we had multiple sites that would use the mold tools in production. Then we'd also do all of the finish work, all of the assembly work. We'd do the packaging. So we had automated packaging lines that were doing form, fill, and seal of packages. Then they also had sterilization chambers. So they had these huge, bigger than this room, big, probably 6 of them, big sterilization chambers that they'd put pallets in, and they'd gas the room with ETO, ethylene oxide, and sterilize these things. And then we had a lab that would test all that. So it was pretty cool stuff to learn about. And I made a point of spending my time all around that company, learning about all these processes. And it was just awesome.
Doing the rounds.
Yeah. Yeah, I would go. I made time. If I had to quote extrusion for somebody out of a certain material, go upstairs. I'd get on the extrusion floor. I'd talk to the extrusion, the guy that manages the extrusion floor and say, what does it take to do this? What about these tolerances? What makes it difficult to hit these tolerances, or what tolerances are normal? And, how do you do that? Learn really cool stuff.
I think that's super valuable for engineers to get experience in a few different areas. How did you approach your manager or whoever leadership was and suggest that they allow you to roam around a little bit? Or was it more of asking forgiveness rather than permission?
Yeah, that implies that I asked anybody. The plant was kind of, once you're in the door, it was pretty much open access. Employees could go pretty much wherever they want. We did have passes, but at least at the engineering level, you could get into anywhere. So I don't remember asking my boss. It was somewhat hands off, but I do remember just, if I had to do an extrusion, somebody might have said, oh, well, they do that in the other building, or they do that upstairs. And I just wander over there and walk in. Sometimes I just spend my days wandering around, seeing what I could find, see what cool machines I could find to look at.
Yeah. Huh. Never got in trouble?
No, never got in trouble. Yeah.
A smart engineering manager would see that and say, kudos for you, keep it up.
Yeah. I just found it was important for me because I was a little bit shocked when I started my first professional job. I kind of expected some kind of training program, or like that I would be assigned a mentor, or that the other engineers would be able to teach me stuff. And I expected, oh, these guys are going to be doing all kinds of calculations and all this fancy engineering. And it wasn't like that at all. It was kind of thrown in a cube and, given a few drawings or some parts and said, well, that's where it's made. These are what you have to do. The sales guys are going to come in and ask you for variations on this. And then you go do it.
I think that's probably the case for most engineers. Even, Braun is a huge company, a lot of other big companies out there. I haven't worked for any very large companies. I've always worked for small companies. But even the small company I started with, I remember my first full-time engineering job thinking, okay, I'm going to go in, I'm going to use all this calculus and physics equations that I've learned in college, and it's going to be very regimented. There's going to be like a detailed process for everything.
Right.
Not the case.
Yeah.
Yeah. Yeah.
I remember being disappointed, and I kind of made a pact with myself. I'm like, look, I didn't spend all that time in engineering school to not do engineering. Like, nobody else is using it. I'm going to make a point of using it myself. I'm going to just be rigid about it for myself, be disciplined.
Can you think of any stories that you can share where you really did have to use engineering? It wasn't just get in CAD and model something that looks about right, about the right size, but you actually had to use engineering or else the project would have failed.
Yeah. There's been many. Let's see. One I can think of in particular. We had a company come to us that wanted to wind like 15-foot to 20-foot lengths of really fine gauge wire. And they wanted to wind it on they wanted to pack, let's see, it had to get wound on some posts so that it can subsequently get packed into a product. And it had to be wound in a figure-8 pattern so that when it was unspooled, it didn't tangle at all, right? So it's a little bit of an uncommon winding for a wire. At the time I was working for ATS, and they had in Canada, there's a big automation company worldwide, and they have multiple kind of business units. And one of their business units was specifically motor winding. That's all they do, motor winding. And when the project first came to ATS, it originally went to the motor winding division, and because it's wire winding, right in their wheelhouse. And they said, nah, we're not going to quote it. We're not going to do it. We don't see how it's going to work. So it ended up coming to the smaller division that I was at, and we looked at it, and they're like, do you think we can do it? I'm like, well, probably. There's probably some way to do it, right? So it had to be wound very fast and in a small figure-8 pattern. And you can imagine the accelerations as you start upping the RPMs, you're changing direction 100%, right, in a small corner. So there's big acceleration. So it had to be very light. It It had to be very stiff and had to be very fast. And to figure out, I mean, it used engineering in all kinds of ways. First, I had to figure out the path and what the path would take. And then I had to calculate, well, what are the maximum accelerations going to be and in what direction? So there was a lot of trig, a lot of math. I know I actually, to check all of my math, when I designed it up in CAD, I ended up plotting it and did a graphical back calculation, basically to see that the accelerations I was calculating were actually what I was going to see with the motion. So there was a lot of work there doing that type of thing.
How have you kept your math skills up to date? Because I know personally, I haven't used much math.
Yeah.
I got into mechanical design kind of right away out of college, and CAD does the math for you in many instances, most ways. And there's a little bit of algebra here and there, right? But I can't count once that I had to use calculus or get deep into physics equations. That was never the kind of work that I had for whatever reason. But how have you kept your technical, your math skills, your physics skills up to date?
Well, math skills, I'd say, I don't know that I have. I try to use math whenever I can. I like making Excel spreadsheets. I like writing code that involves, mathematical equations. I look a lot of stuff up. I have to reread a lot of things, like, oh, I remember kind of how to do this, but not exactly. So I'll look it up. I think just to keep sharp, I just apply it when I can. If I think that it's something that can be calculated mathematically and I think it'll be useful, I'll put the effort into doing it versus shortcutting it.
Just looking for opportunity.
Yeah, look for opportunities.
Yeah.
Physics, I would say, I just love learning about science and physics all the time. So I read a lot of technical books, like textbook style books, and also more popular science type things. So I just really enjoy learning about that stuff.
You mentioned earlier that you'll read things to understand. You'll go search on Google, you'll read there. We had a project recently where you had to read an entire user manual for a robot. Mm-hmm. We won't mention the robot name because it was a pain to work with and we don't want to throw anyone under the bus, but you took the time, and I don't think many people would do this. You took the time to read this entire manual, which was what, a couple hundred pages or something?
So several manuals, actually.
Several manuals. And I think you mentioned you read them more than once. Even. Yeah. So how does that happen? Because again, I think 98 out of 100 engineers are not going to spend the time to do that, but you did. Why did you? What was the impact to the project and your own education, and any insights or tips that you can share around that?
Yeah, unlike normal people, unlike most people, I somewhat enjoy reading technical manuals. And there's kind of this joke in tech support about, RTFM, like most people could figure out if they read the fucking manual. And I think I maybe set the stage for this skill at the first job where I was given the opportunity to be a controls engineer. So we were working on a project, and it was using a Delta Tau controller, and that's a kind of high-end servo controller, especially back then. It was pretty high-end. And multi-axis and very fast and can do all kinds of things. And the language it uses is somewhat like a C language code, right? So it's not the typical ladder logic type thing. And we had an older kind of crusty ladder logic controls engineer guy, right? And he was working on this system, and we were using linear motors, which was also relatively new at the time. This is back in the late 90s. I had done the vision on the system. That was my first introduction to controls engineering. I was asked to learn how to do machine vision, which was kind of early at the time, one of the early Cognex systems. And so I was sort of part of this, getting this machine to work, right? And the guy was struggling. He just couldn't figure it out. And so I asked him, like, hey, well, do you, I don't know anything about it, but do you have any manuals? Like, I'll read up on it. And at the time, they were printed. and they were 2 or 3 manuals like this thick, right? Big manuals. It's like, oh, that's juicy. It's going to take a while. But I took it home and I read through them several times, and it was just fascinating to me, like all the possibilities of what you could do. And I found that by reading through them, like it really gave me an understanding of just how this thing, I mean, obviously it's a manual, right? That's the point of how this thing worked and what I could potentially do with it. And I got excited about all that. And eventually I ended up, the guy never got it to work. And I told the boss, I'm like, hey, I think I could take a crack at this, let me try it. And then I got it running, and then we got it to the customer. So that was my first introduction. But that kind of set the stage for, hey, there's information out there, and if you take the time to read it and understand it, you can learn just about anything. You can do all kinds of stuff that looks like it's magic, right? That you need, schooling and years of training and all this kind of thing. But the information's out there.
Especially these days, there's so much information out there. Yeah. Mm-hmm. Okay, so that was your introduction into controls. Did you ever make a conscious decision that I want to move from mechanical engineering, mechanical design into the world of controls and software? Or was it more of a gradual environmental change that was wrought upon you?
Yeah, it was kind of organic. I was introduced to software engineering in school. We did Fortran at the time, but I was always thought it was really cool. It was amazing what you can do with software, and always want to understand how computers work. I don't like using things that I don't understand, at least the basics of how they function, like my car, my phone, my computer. People, yeah. So I always wanted to understand how computers work and how electronics worked and how software worked. But like I said, I focused on the mechanical engineering. So after school, I did take some additional college courses on like C, C++, and object-oriented programming, that kind of thing, just because I was interested. But there was not really a conscious decision. I always wanted to do it, but to this day, I still struggle with not doing mechanical design. Like, which one do I want to focus on? What do I do with my hands? Like, it's difficult. I can get really in the flow, really focused on mechanical designs and get excited about it and have a great time solving problems. There's tons of cool problems to solve there. And at the same time, I feel the same way with software. I think I am more gravitating towards software at this point in my career. It speaks to me for several reasons, that it's very obviously logical and structured, and it's quick turnaround for changes, and being a somewhat obsessive compulsive control freak, I have complete control over what I'm doing in that arena most of the time. And I like that.
So you've got pretty deep skill sets, both in mechanical design and controls software. How has having both of those skill sets impacted your career?
It's made me a really, I think, well-rounded systems thinker, which seems to be appreciated in my career, because I tend to look at things holistically. So when I'm designing something, I naturally think of it through its entire life cycle, I would say. Like, okay, how are we going to, how's it going to work? Sure. But how are we going to manufacture it? How are we going to assemble it? How are we going to adjust it? How is someone going to actually use it? Like, what's important to them and what do they not want to worry about? And then, man, somebody's got to support this. Like, what are they going to need to support this to make it easy to, keep using it for years and years? And I kind of gained that by getting in early on mechanical design, and maybe this working at some of these companies where they were vertically integrated, right? And you'd see the whole process. You could understand a lot of this stuff and made it real. But when I first started being a controls engineer, I really got that last part of how do you debug it and maintain it, which ends up being the same as kind of supporting it long term, right? And I realized that, man, there's some decisions that are made that seem like they're time savers or is going to make it a little bit less expensive and really make it impossible or very uncomfortable to support when it's on the floor. Like adjustments with slotted holes, and they're not precise, and you tighten them down and they move, right? So you're trying to adjust, like, I don't know, a camera or something, and you get it exactly where you want it, and you start tightening the bolts and it's moving a little bit, and you're trying to tap it with a hammer to get it back. I've worked on so many machines that have, inaccessible adjustments that you can't tighten without moving, things that aren't adjustable that you end up, you need to adjust, or parameters that would be great if they could be changed because things change over time in the machine, or you get new batch of parts, or you have to replace something on the machine, and now you want to adjust these parameters and they're just not available on the HMI, right? So you have to dig through the code and change it. And the more and more I had to do this, and the more I had to support my own designs and support my own code, be the guy that got called to the field, or be the guy that, debugged it, showed the operator, showed them how to use it, and then was the support. These things start becoming really important to you. And these days when I approach designs, I think about it in that way. I try to think about the full life cycle. And in particular, where I am now, I'm like, okay, I'm the most likely guy to get called. I don't want to get called. I don't want phone calls. I want them to be able to do it. I want them to be able to do it. I want them to be happy about how they're doing it. And, never hear from them again, except for new equipment.
This could be a great topic to dig into in greater detail in a future segment where you show us a couple of examples of specific things you've done to set up your code. Could even be mechanical designs as well, but how you set things up in the beginning so that they're very easy to service and manage in the future.
Right. Yeah, I think I've also bounced between custom equipment and product, right? So it's a big difference when you're designing an automated machine that's a custom piece of equipment versus designing an automated machine that's going to be produced on a production line, and you're going to make, hundreds of them or thousands of them, and they're going to be sent out into places that are not industrial, right? That don't have mechanics on hand, don't have technicians and engineers necessarily to look at them. So that's been interesting to see that side of it as well.
I imagine there are going to be people watching this thinking to themselves, man, this guy Matt, he really seems like he knows what he's talking about. How did you get there? I know it's not a short, quick answer, but is the answer just, I kept being curious and kept putting myself in situations where I could learn more, and even taking the time, sometimes even my own personal time, to learn more? Is it just curiosity and time, or are there other elements you think that have contributed?
Well, I think I'm fortunate in that I had a decent education, and parents who taught me to be curious and were curious themselves. I've always personally loved learning new things. Let's see. I think I lost the question.
The question is the success and knowledge that you've gained to date.
Right.
Is it basically a result of curiosity and time?
Yeah.
Or do you think there are other factors that have gone into that equation?
Certainly curiosity and time. I've always wanted to do things to the best of my ability, and I've always wanted to improve things, right?
Yeah.
So I never liked when I'd be given a project or hear somebody working on a project and they say, oh, just do it like this is what we did before, or I'd ask about something and they say, well, that's how we've always done it. That works fine. It's good enough. I never liked good enough. I always thought, well, we're doing it, like we should put the effort into making it as good as we can.
Yeah.
And then a lot of curiosity and time. I just have natural curiosity. I get bored doing the same thing over and over again. I like to learn new things. I like to understand not just part of a machine, but I like to understand the entire machine as much as is reasonably possible. It's just interesting to me.
Here's a philosophical question. You just like to learn. You're naturally curious. Do these things, you're just blessed because that's in your genetics? Or have you ever had to try to be curious or try to want to learn more? I guess the question is, not you specifically even, but curiosity and wanting to learn more. Are these behaviors that can be fostered, or is it you either have these innate behaviors or you don't?
It's hard for me to say. I think either by circumstances or by genetics, I have them. So I didn't necessarily have to develop it. I do know, like, I've always loved to read. My mom's a voracious reader, and she read to me as a child. And I've always, we'd go to the library. It was a big deal. Like, we'd go to the library and I'd check out the max, 10 books every time, right? And I'd go home and read them. But they were all typically, either about karate, how to do different karate moves, or they were novels, right? One of the ones I used to love to get were the Tom Swift books. Do you remember, that one? So Tom Swift is a kind of older sci-fi book, and it's about this, I think he was a teenager maybe, this boy, I believe it's been a long time. I believe he had a wealthy family, and he was like this kid who was an inventor. And actually the taser that name comes from Tom Swift. So it was Tom Swift's electric rifle.
Really?
Yeah.
Huh.
Tom A. Swift's electric rifle. That's where the taser comes from. So he in one of his books had invented electric rifle, I think. But he would invent all these things. I don't even remember the premise of the stories at this point. It's been so long. But, he'd have these adventures and he'd have to invent stuff to solve them. And I remember finding that interesting. But I never really read to learn. I guess I never really read to learn. I was reading for fun at that time except for karate moves. I was big on that. Until I got that book from my dad about the engineering. That was the first time I had read a technical book for fun. Like, it wasn't a story. It was teaching me about the world.
Yeah.
And I couldn't believe how excited I was to read it. And then after that, I remember I started going to the library, and instead of looking in science fiction or fiction, I would go to engineering, and taking out all these books and how engines work kind of thing or something, right? And I'd started reading those types of books.
Yeah.
And just caught fire. So.
All right, well, we'll just do a few minutes more, then we'll wrap things up here. For engineers out there who are listening to this and thinking, man, I would love to shift my career like that also, whether it's from mechanical to electrical or from electrical to chemical or whatever it is. Do you have any advice that engineers can use to make a smooth transition from one discipline to another?
Yeah. I can tell you kind of how I did it, I guess, and how I would recommend. So, it'd be very rare for someone to, if you're I was a mechanical engineer when I started out. It'd be kind of rare for someone to just offer you, hey, you want to do some controls engineering? You want to come up with some electrical schematics? That just doesn't naturally happen. It's not efficient,
Yeah.
right? It doesn't make sense. So I realized if I wanted to learn about these things, I had to do it on my own first. And then I had to start associating and asking questions of the people who do it and show them my interest. And then I started looking for, hey, can I do that part of that project, or whatever. And then, when you're out offering to help somebody, they'll typically let you. So I'd start taking pieces of things, and the more I knew, the easier it got and the more responsibility they give me.
So the work that you did on your own to learn some of the basics, you're basically de-risking it for the person you were pitching to, saying, oh, you should let me help with this.
Yeah. Instead of just coming in blind and say, hey, I don't know anything about this. Why don't you teach me something?
Pay me so that I can learn this thing.
Yeah. I'd say, hey, I've been reading up on this, or, I understand this level of this whatever we're working on, right? Like, oh, I read all the manuals for the Delta Tau controller, and I think what we need to do is this, that kind of thing. And then, what do you think if I try that? And then they'd be like, yeah, it sounds like you might know something. And I didn't know anything really. The first machines I did were, looking back, they're so bad. They were so bad. And the first code I wrote was, so shaky.
Well, we all have to start somewhere.
Yeah, exactly.
All right. Well, this has been great. Matt, thank you so much for being willing to share some of your
Anytime.
background and experience. And I have a couple of ideas already for future segments that we can do where we dive deep into a couple of areas.
Sounds good.
All right.
Talking to you.
Thanks, man.
You're welcome.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.